In 1892, Rudolf Diesel invented a different kind of engine. It wasn't like the one that Otto had made, which is our internal combustion engine of today with spark plugs, but instead it was an engine that did ignition based solely on compression. It became known as the diesel engine. The key in these engines is something called compression ratio. And that compression ratio is the ratio of the cylinder when the piston is all the way up, so that your only volume is this, compared to when the piston is all the way down and your volume is this big. This is a measure of how much power you can get from an engine. For a given size of cylinder, therefore a given size of engine, if you have a larger compression ratio, you can get more power, more energy per unit time from the engine. So one of the problems with making a very large compression ratio is that as you're moving this cylinder up and you're compressing the fuel-air mixture, it might spontaneously explode. That's what happens in car engines when you hear a knock. It explodes before the spark plug, the thing that sits in here, right? And it produces a spark that ignites the fuel mixture in an internal combustion engine in an Otto cycle, OTTO, as opposed to diesel. Otto cycle has a spark plug. A diesel has no spark plug. It relies on that spontaneous ignition by compression. So you might say, oh, isn't the diesel engine terribly unreliable? Doesn't it knock all the time? Well, it doesn't, because they use different fuel. The thing with the spark plug, our internal combustion engine, it uses gasoline. All right? And gasoline is almost predominantly all octane. It's something with 8 carbons. There's a few others near there. But diesel does not use gasoline. It uses diesel fuel. That way you're not confused as to what engine type it uses. And it has things that have between 10 and 15 carbons. But it's not just that this has longer carbon chains. These are predominantly cyclic carbon chains that go in some type of manner with maybe some other things stuck onto them. Whereas gasoline is in linear chains, maybe some branches, but not carbon chains that go around in a circle. These are much more explosive. Gasoline is one of the most dangerous substances that you can go get easily commercially. When I do demonstrations in class, I don't blow up gasoline. And as you know, I like to blow up stuff. It's way too dangerous. Diesel fuel, on the other hand, which I made the mistake once when I was trying to burn a manure pile, I thought, oh, this is great. Oh, gasoline's kind of dangerous. I don't want to pour gasoline all over it. I'll pour diesel fuel all over it. Since I had a diesel tractor, had some anyway, and then you very carefully go to try to light it, and it didn't even light. Diesel fuel is not near as volatile. And this means you can have, with the diesel fuel, a higher compression ratio. You can get more power out of an engine the same size. It needs to be a bit heavier, though. It needs to be thicker. If you're compressing this more, the strengths of the cylinders need to be there, and therefore the diesel engines are typically, not always, but typically also larger in size. Higher compression ratio, higher power, because the fuel does not spontaneously combust as easily. There's another difference between these engines as well. In the diesel engine, the air is compressed and then the fuel is squirted in. And when you compress air, it gets hot. So when that fuel gets squirted in, boom, that's when you get your ignition without the need of a spark plug. Whereas in the normal gasoline-based Otto cycle, normal internal combustion engine, the fuel and air mixture is compressed at the same time. A disadvantage of diesel engines is that in the winter, when things are very cold, even if you squirt that fuel in, the air is not hot enough to ignite it. So if you go out on a really cold winter day in the farm and you try to start up your diesel tractor, it just doesn't move. You need something called glow plugs. They're not spark plugs. What they are is something that actually warms up the cylinder. It's like a little electric heater inside your cylinder, so it gets warm enough so that when the diesel fuel is squirted in, the air is hot enough to actually ignite it. So other than this disadvantage that diesel engines need to have some special care taken if you're going to use them in cold climates, they can be more efficient for the weight of the engine. But the weight of those engines is much larger. So a diesel engine looks very much like an internal combustion engine. It still has cylinders, it still has a crankshaft, it still has pretty much all of the pieces except a different way that the fuel and timing that the fuel is injected, and of course that larger compression ratio. Because these engines are larger, that's what we use to have the most efficient transportation for giant trucks like the big 18-wheelers, and also for locomotives, for rail car engines. They run on diesel fuel for the same reason that they have large diesel engines, typically that actually run an electric motor, sort of the diesel generator that makes the electric motor like a hybrid car. But the same principle that a locomotive and a large long-haul truck have a lot of weight and can afford the weight of the engine, you want for that given weight and power the most efficient solution, which is the diesel engine.